Okay, let's solve this question. I have a matrix again. So there is this matrix of m cross n. And now there are q queries, okay? There are q queries, you have to answer all those queries. Every query contains 4 integers. The 4 integers are I1, J1 and I2, J2. And I1, J1, I2, J2 are, so basically I1, J1 denotes a cell in this matrix, a particular coordinate in this matrix, and I2, J2 also denotes a particular coordinate in the same matrix, okay? And this basically denotes your top left and this denotes your bottom right. You can assume that the input I1, J1 and I2, J2 are same enough to denote top left and bottom right, okay? You can just assume that. So all that you have to do is that you have to tell the answer should be sum of this submatrix. So for any input like this, you have to tell me what will be the sum of submatrix whose top left is I1, J1, and bottom right is I2, J2. Whatever is the sum of this, that should be the output to a particular query. Okay, it's I think pretty straightforward statement. I have seen many interviewers asking it when they wish to ask some questions of pre-computations and all. So what is the naive way to do this? It is same, we just have to consider element between them. No, this is what happens. This is called as bias. When you learn something, then you see that thing everywhere. Sometimes it's good, other times it's bad. So let's say you pick a cell over here and you try to apply the previous formula. So applying previous formula, you will end up considering some other submatrices also to which it belongs, to which that element belongs. But you do not need to consider other submatrices. Here, you just have to tell me the sum of this submatrix. Everyone can write a working brute force solution to it. Everyone can do that, right? So it means that whatever is given to you, you simply do that, okay? Isn't the top left and bottom right as the previous one? Then you get it. See, the previous question asked you not to tell the sum of a particular submatrix. This question is composed of q different queries, and every query implies a particular submatrix, and you have to tell me the sum of that particular submatrix. In the previous question, the statement was that there is a matrix, and now you tell me the sum of all the submatrices. That is the key difference. So there you were computing sum of all the submatrices. Here, for a query, you need to tell me the sum of a particular submatrix denoted by that query. So what do I do here? Yeah, tell me. So everyone can solve it in a brute force manner, that given I1, J1, I2, J2, just figure out the sum from I1, J1 to I2, J2, and there are q queries. In the worst case, your I1, J1 can be 0, 0 and I2, J2 can be m minus 1, n minus 1. For that case, it will take m into n. So I can say that if I do that in the worst case, the overall time complexity of executing all the q queries will be q into m into n. Do you see why I am saying the time complexity would be q into m into n if I use the brute force approach? That should be clear to all, right? Because brute force approach simply computes the sum of all the cells involved in that submatrix. And the largest submatrix can be of m cross n, so it will be this much of time complexity. Now the question is that can I optimize it? Or maybe let me reduce the dimension of question for a while, okay? So let me ask you that, hey, what if it was an integer array which was of size n? What if it was an integer array of size n and then there were q queries, and then every query was of form I comma j. Every query was of form I comma j, and I comma j denotes a particular subarray, and answer of every query should be nothing but the sum of that subarray. How many of you can solve it easily? Yes, you can solve it easily using prefix sum approach, right? Because in every query, you need to, given some I1, J1, you need to tell me the sum from index I1 to index J1, okay? Now if you have pre-computed the prefix sums, if you know the sum from here to here, you subtract that from this and then you will get this much of sum. So if you have converted your array into a prefix sum array, then every query can be answered as return prefix sum till j1 minus prefix sum till I1 minus 1. So in this case, every query is answered in order 1 time. So what will be the time complexity of this approach? The time complexity of this approach will be, first you have to convert the array into prefix sum array. This conversion part, how much time will it take? The conversion part will take you order n time, right? Somebody is writing order n into q, which is incorrect. Conversion part will take you order n time, and then every query is being answered in order 1 time. So order n time for this pre-computation and order q time to execute all the queries. So the complexity will be order of n plus q. For n dimension, we need to have n. Yes, you need to have n dimension prefix sum. Great. So that is the thing over here. So this was 1 dimension, so your prefix sums were 1 dimensional. Now you would wonder that here I need a prefix sum but in 2 dimension. So it's good to wonder, keep wondering more, that what is the meaning of prefix sum in 2 dimension? What does it even mean? If you are able to crack that, then you'll feel great about it, and then the question will be automatically solved. So think how you can get, I was trying to say this thing in the first question also. See, you have to be wary about this thing, okay? Sometimes when your I1 is 0, then don't perform this, because when your I1 is 0, then whatever is prefix sum ending at J1, that is your answer, because prefix sum ending at J1 is sum from 0 to J1. So in that, whenever your I1 is 0, you do not need to write this second term. Does it make sense to all? Otherwise some of you will make some these useless errors. Prefix sum left to right and up to down. Yes, that is correct. That is perfect. So let us understand that, guys. It is an interesting thing. So now stop doing whatever you are doing. I have to draw a lot of things on the board, and that means you have to see a lot of things on the board. So just keep your attention on the board only. Let's say there was a matrix like this. Okay. And there were some columns and there were some rows. Let's say this was I1, J1, okay? And let's say this was I2, J2. So I need to find this sum somehow. I can find it in a brute force manner, but I don't want brute force every time. I want something efficient. So how do I do that? Let us all understand it, okay? So guys, first understand one thing. I am going to say that, hey, I am going to transform this matrix into a different kind of matrix. Now, what that different kind of matrix will do is that whatever will be the sum at a particular cell, let's say this cell, it will contain the sum of this submatrix. Okay, so matrix of Ij should contain the sum of, it should contain the sum of the submatrix whose top left is 0, 0 and bottom right is Ij. So matrix of Ij, the value stored here should be the sum of all the elements present in this. And now the same thing applies to this. What will be this value? This value will be the sum of the submatrix, which is this. This will be contained here. Any other cell, if you contain this cell, the value over here will be the sum of these many things. The value here will be the sum of these many things. This is how it would look like. So now just tell me one thing. If I have able to translate this matrix into such a kind of matrix, then I can say that, hey, this sum can be calculated one by one. How one by one? First, I need to find out that what is the sum of this much part. The sum of this much part will be contained here, and this value is matrix I2, J2. Now, you know, you would want to reduce some things from here. You would want to minus some things from this value. So first tell me, would you want to minus this thing or not? Because this thing has appeared in this entire thing. So you would want to minus the answer of this part from the overall thing. And how do I minus that? So whatever is the sum of all these elements, that would be stored here. And can you tell me the coordinates of this? It is pretty easy to say. So just tell me the coordinates of this. You have been given I1, J1, I2, J2. You should be able to tell that. Yes, I1 minus 1, comma J2. Is that visible to all? I1 minus 1, J2? It will be, right? Because if this cell is in row I1, the previous row is I1 minus 1 and this column is same as J2. So this thing is I1 minus 1, comma J2. So I will minus from here I1 minus 1 J2. Okay. So I have minused this thing. But I should minus this thing also, yes or no? This part is also to be minused, right? Yeah. And where will the sum of this part be stored? So the sum of all these elements will be stored at this cell. And what will this cell be? This cell lies in I2 row and column is just one behind this column. So it will be, row number will be I2 and column number will be J1 minus 1. So I have to subtract matrix of I2 J1 minus 1. So what I did was that this entire sum I took first. It is present in this. Now from this I subtracted this much of area and then I subtracted this much of area, which is this. So when I do that, what I'll get is this area. Do you think that? Do you think that the result of this will give me the remaining area? Okay, this has been subtracted 2 times. So if you have subtracted it 2 times, you need to add it back once. And can you add it back once? Very easily. How? Because if this is I1 J1, this will be I1 minus 1, comma J1 minus 1. Okay, and the sum of these things will be stored in this cell. So I need to add back matrix of I1 minus 1, comma J1 minus 1. So I can use this equation, and this equation can be used in order one time, and I can figure out the sum of this much part if this transformation is done. For now, you imagine that this transformation is done. You just imagine somebody did it for you. Now you can easily use this and answer it. So this is the most important part. Now all that I need to do is I somehow need to transform my matrix into such a matrix that the value over here should store the sum of this entire thing. The value over here should store the sum of this entire thing. How do I do that? So let us learn how to do that. So it's a very easy technique, but again very, very profound. Okay. So what I can do is something like this. Let's say I had a matrix containing elements. Let's say the elements were A, B, C, D, E, F, G, H, I. So first what I will do is I will do prefix sum in every row. So I will do prefix sum in every row. When I do prefix sum in every row, this will get translated to something like this. It will be A, it will be A plus B, it will be A plus B plus C, D, D plus E, D plus E plus F, G, G plus H, G plus H plus I. And now I need you to do prefix sum in every column. If you do prefix sum in every column after this, see what happens. So if you do prefix sum in every column, this will be A, this will be A plus D, this will be A plus D plus G, this will be A plus B, A plus B plus D plus E, A plus B plus D plus E plus G plus H, and this is A plus B plus C, A plus B plus C plus D plus E plus F, and this is A plus B plus C plus D plus E plus F plus G, H and I. So now if you take a look, what do you wanted here? You wanted here the sum of these things to come, right? And the sum of these things is A plus B plus C plus D plus E plus F, right? You wanted here the sum of these things, which is A plus D plus G. You wanted here the sum of these many things, which is A plus B plus D plus E plus G plus H. So you can see that this transformation has successfully been achieved, right? All of you see that? Now we will understand why does this approach work. So you know, it is very easy to see why this approach works. So first you are doing prefix sum in every row. Okay, so again let me take an example. So I'm taking a generic example. Let's talk about this cell. You want that this cell should contain the sum of this entire thing, right? Now when you are doing prefix sum, that was your first step, prefix sum. So when you do prefix sum, all these values slide here. By that I mean all these sums slide here, all these sums slide here, and all these sums slide here. Now when you do the sum in column, it's just like that all these have dropped here, all these have dropped here, and all these are already here, right? So that's the simple reason. So first you do prefix sum in one dimension, then everything of one dimension has been prefix summed in that dimension. Now when you do that thing in second dimension also, then you are doing it for second dimension, but for one dimension it was already done. So it's just like that you have achieved it for both the dimensions. So you can perform this transformation. How much time will this transformation take? This is like your pre-computation step. So what will be complexity of this? N square. Yeah, that's right. So in n square or n into m basically, that is more generic. So in n into m time, you can easily first perform prefix sum in every row, get to this, then prefix sum in every column, get to this. And once you have this, then for every query, you just have to use this, because every query will supply you I1, J1, I2, J2, and that's it, done. Makes sense to everyone? So what is the important learning here? Again, that prefix sum. So yesterday we were learning about prefix max, suffix max. Today we see that the same thing, but their version is sum, and that we are saying not in just one dimension, that we are saying in two dimensions also, right? I'll just like to tell you one thing. Whenever you are playing around with indices, actually you are playing around with indices mean that you are doing -1, -1, -1. So you have to be very, very careful, because certain times when I1 is 0, that case you don't have to do it, okay? Again, if J1 is 0, you don't have to do it. If I1, J1 both are 0, you don't have to do it. So you have to be careful about this, and you know which kind of cases this will be. This can be a case like this. So let's say this was the matrix, and the query is asking you for this much of sum. So if the query is asking you for this much of sum, you will first figure out this thing, okay, which is this, which will denote the sum of this much part. And now from this, there is no upper part to remove, okay, there is just this part to remove. So you will just remove this part, and there is no this part also, okay. So it can happen that your input is such that one of the parts which is to be removed does not actually exist only. Certain times what can happen is that your input was something like this. In this case, you will first get this value, which is the sum of this much part. Now there is no left part to remove, there is just up part to remove. So certain times this kind of cases will come, so you have to just ignore these expressions, you don't have to write them up, right? So just be careful about it, okay, while you are writing the code, otherwise you will get runtime errors everywhere. Okay, another approach will be to copy all elements into another matrix order n square and time order n square with old approach. Yeah, I mean you would want to not transform the same matrix if this is not allowed to be changed. If somebody tells you that this is a read-only matrix, then you would obviously want to copy it into something else and then do these transformations into that something else, okay. So still the time and space complexity, everything would be the same, okay. Space complexity would increase because you are building another 2D matrix of size n square or m into n, whatsoever it is. Okay, so is everything clear to all? Time complexity and the approach, because now I need to move on to something else. So now one thing that you guys should understand is that certain times what can happen is that this matrix was static. Okay, this static is not like static keyword of Java. Please do not confuse it with that. By static, I mean to say that none of the values were changing. So sometimes what can happen that queries are being fired, and in between queries, so let's say there was a query 3 and then there was a query 4, and in between them there was an update. So update means that it says that, hey, whatever is the value at I, j, you update it to something like 99. So if there are updates in between the queries, then will this approach work? It will not, right? So this approach will work if and only if Your matrix is static if the updates are not happening. If updates are happening, then it becomes a little complicated problem, which we'll learn down the line how to solve and all. Yes, in that case, when you go ahead and update some matrix, then it would be again, like order n square thing again. So it would be like that for every update, you are taking order n square. So that would again de-optimize your entire thing.